Hello and welcome to our fifth and final unit, integrals. So we've made it. We've done a lot of work in derivatives and now we're doing a new lesson, integrals, but guess what? Integrals are all connected to derivatives. Basically, calculus is work with derivatives. So today we're going to just learn just a simple definition what an antiderivative is. There's a formula sheet that I gave to you in your package, so it's this pink sheet. So we've got some antiderivative formulas on the front, and then when we get to integrals, I type some up on the back. There's some jokes at the bottom, which may mean nothing to you, but once you learn what an integral is, wow, that'll be a funny joke. We're learning about derivatives, the derivative club. That joke was funny last year. I don't know if that still is a year later. We'll find out. Then this little Batman and Robin one, I'll explain to you what that means right away. Okay, so what is an antiderivative? Well, it's pretty literal. Antiderivative, right? We know what derivatives are. We've just spent the last 2 months learning about derivatives. Now we're going to learn an antiderivative. So anti-differentiation, just going backwards. We've just spent 2 months where I say, here's the function, what's the derivative? This unit, I'm going to say, this is the derivative, what was the initial function? So that's all we're doing to conclude this unit. So just some examples and some definitions. Today we're just going to practice working with that, and then we'll build up our knowledge of the integrals and formulas later this unit. So what's the derivative of x squared? That's really easy for us at this point, right? The derivative of x squared is 2x. So this unit, we're going to do the opposite. I'm going to say, so last unit I would have said, what's the derivative of x squared? You would have said 2x. If I tell you the derivative is 2x, what was the starting function? So the antiderivative of 2x would be x squared. We're just doing the opposite. But is it x squared? X squared is correct, but that's not the only one. So we say antiderivatives aren't unique, right? Because there's other derivatives that could have, there's other functions that could have given that derivative. It could have just been x squared on its own, but maybe it could have been x squared plus 5, right? What's the derivative of x squared plus 5? Still would have been 2x. So it could have been x squared, could have been x squared with a number, could have been x squared minus a number. These three functions all give us the same derivative. So the antiderivative is not unique. So what we do to account for that, it could have been no number, could have been a positive, could have been a negative. How do we account for all cases? We say that the most general one, we put that plus c at the end to show c could have been 0, could have been positive, could have been negative. Because there's more than one function that gives you a derivative of 2x. Hopefully that made sense. Okay, if not, well, we'll keep practicing. So on the next screen, we've got our first formula for this unit, antiderivative. So the most general antiderivative of x to the power of something, so that's an r, x to the power of r. To get the most general antiderivative, we now add 1 to each. Remember, for derivatives, we were subtracting 1, so we go the other way, you add. So you would add 1 to the numerator, degree in the numerator, and then that would be r plus 1. That's all just r plus 1. That's not supposed to be like an exponent, r plus 1. And then we put plus c afterwards to count for the most general antiderivative. And as you work through, that's a common mistake, is to forget to put the plus c at the end. So once you do your homework, you'll see why this is so funny, why Batman's so mad at Robin. It says, I just found the antiderivative. You forgot plus c. That may not be funny, but you'd be surprised. Don't actually hit someone when you do your work, but you'd be surprised how many times when we're doing our work, forget to do that plus c. So just don't forget to put the plus c to make it the most general antiderivative. Okay, so today we're just going to learn what an antiderivative is, just do some practice with some basic rules so we can build on that for the rest of the unit. So in the first example, we want to find the most general antiderivative f of x. So this is the capital F of x. So I've given you the derivative. We're going to work backwards to get the antiderivative. So for the first one, it's x to the power of 4. So I just showed you that rule on the other slide, and I do have it on this pink sheet here, so if you follow along. So to get the most general antiderivative, we would add 1. So x to the 4th becomes x to the 5th. Then that exponent becomes the denominator, and then plus c. And that's it. That's the most general antiderivative. So it's not that hard. Let's try another one that's a little bit harder. F of x is 3x squared. So if that's the derivative, what's the antiderivative? So again, you add 1, so 2 becomes 3. And then that exponent becomes the denominator. And don't forget to put the plus c. But if you can clean it up a bit, you can. That would be good to do so. So the 3's cancel out, so we should write it as just x cubed plus c. So don't forget to look to see if you can simplify a bit. Okay, not that bad. So like I said, we just get the basic understanding today. That will make the rest of the unit easier. Let's try a couple more examples. Ooh, getting a little bit longer. F of x is 4x squared minus 8x plus 1. So if that's the derivative, what's the antiderivative? So again, you add 1. 2 plus 1 is 3. And then your denominator is 3. Now there's no number there, but if there's no number there, it's a 1. 1 plus 1 is 2. 2. And again, technically, this is x to the power of 0. That's why there's no variable. So 0 plus 1 is x. So technically it's 1, 1. And again, we can clean that up a little bit. It's okay to keep the fractions, but hopefully we know that minus 8 divided by 2 is minus 4. And then we would just put it like this. Oh, and do you notice I have a mistake already? What did I forget? Forget the plus c. So remember when we do the most general antiderivative, you do have to put the plus c at the end. Okay, just a couple more examples, but I think hopefully we're getting the idea. Oh, they're getting a little more fun. This is more calculus level now. So the square root of x cubed minus 1/2 x to the power of minus 2 plus 5. Now what I did is I just changed this to 3 over 2 because I find it a little bit easier to work with. You don't have to if you can do the mental math. And again, we add 1 to the exponents. So what's 3 over 2 plus 1? 3 over 2 plus 1 is just 3 over 2 plus 2 over 2. So this becomes 5 over 2. But remember, you have to put it like that. Okay, so we're getting some fraction work. That's okay. Now I'm going to write it like this. We have minus 1/2. We've got the x there. Minus 2 plus 1 is just minus 1. And we have to put up minus 1 down there. And then again, there's no term. That's technically x to the power of 0. 0 plus 1 is 1. So that's just 5x. You can do 5x1 or just 5x. And again, don't forget the plus c. That's my rough work that's getting in the way. And I can clean this up a little bit. How do you divide a fraction by a fraction? That flips around, so you end up getting 2 over 5, x to the power of 5 over 2. You've got a negative divided by a negative, so this really becomes, and again, it doesn't matter where you keep the x on top or on bottom. I kept mine on top still. Yeah. Just to keep it with your notes, remember minus 1 divided by negative 2 just gives a positive. You could put the x in the bottom, make it a positive, but that's okay. Plus 5x plus c. But just wanted to show you, whoops, how we do some work with some radicals and fractions. But we did practice like that when we did derivatives. Okay, that's it for number 1. And then for question number 2, it's the same idea, but a little bit of an extension. Here they say find f if the derivative is x root x, and we're told that f of 1 is equal to 2. Okay, so how do we do a question like that? Well, the first thing, again, is I converted from radical to exponents because I just find it easier to work with. Root square root of x is the same as x to the power of 1/2. Remember grade 10 math, when you multiply, you add exponents. So that's the same as x to the power of 3 over 2. Okay, now we start by getting the antiderivative. So we add 1. Oh, we just did this on the other screen. 3 over 2 plus 1 is 5 over 2. Which is 5 over 2, but I'm just going to go straight to that because we just did that last example. So this is 2x to the power of 5 over 2 over 5 plus c. But now the question's a little bit different. We have another step. They tell us that f of 1 is equal to 2. So I took this derivative. We know that f of 1 is equal to 2. When I replace all the x's with 1, it gives me a value of 2. So this is just how you find your c value. This hopefully isn't that hard. 1 to the power of that just gives you 2/5. So then you subtract out the 2/5. And then can I make a common denominator correctly this time? Yes, yes. So my c value is 8 over 5. So this time, when they give you that, you can't stop with c. You actually have to put your final value plus 8 over 5. Okay, there you go. So not that hard, but it's a new concept, antiderivatives. We're just doing the opposite of derivatives. So give that a try. Good luck. And like I said, we only have a few more lessons left in this course. So hang in there. And like I say, everything's connecting with what we've learned in previous units. Okay, good luck.